Good afternoon, dear colleagues and guests. Allow the meeting of the Dissertation Council for the thesis of Anastasiya, Pavlovna, Shirokolobova, the degree of Candidate of Physics and Mathematics, specialty 010109, discrete mathematics and mathematical cybernetics, on the topic optimization methods to assessing the demand for transfer between transport hubs to be considered open. The order of St. Petersburg University, of April 2019, 3588/1, myself, Oleg Granichin, Doctor of Physics and Mathematics, Professor of the Department of System Programming at St. Petersburg State University, was appointed Chairman of the Dissertation Council. And let me introduce my fellow council members. Lyudmila Polякova, Doctor of Physics and Mathematics, Professor. Ekaterina Viktorovna Gromova, Doctor of Physics and Mathematics, Professor of the Department of Mathematical Game Theory and Statistical Solutions at St. Petersburg University, and Polyakova Lyudmila Nikolaevna, Doctor of Physics and Mathematics, Professor, Head of Department of Mathematical Theory of Control Systems Modeling. And in remote mode, we have Yerzin Adil Ilyasovich, Doctor of Physics and Mathematics, Novosibirsk State University, and Somendu Raha, Doctor of Physics and Mathematics, Indian Institute of Science. First of all, let me emphasize that according to the federal law number 127 FZ on science and state scientific and technical policies, St. Petersburg University been granted the right to independently award academic degrees. The corresponding order and the procedure for awarding degrees at St. Petersburg State University, on the basis of which we are holding our meeting here, was issued on the 1st of September 2016. Hereinafter, I'll just refer to it as the order. In accordance with this order, a meeting of the Dissertation Council is considered competent if attended by at least 2/3 of the approved composition of the Dissertation Council, but not less than 4 persons. Three council members are present here in person and 2 in remote mode, but thus we have a quorum. Let me establish the following procedure for today's meeting of the Council with a total duration of more than 2 hours. We'll start with a brief report of the Chairman on the main content of the documents submitted by the applicant and their compliance with the established requirements. Answers to possible questions. We have 5 minutes for that. A brief report of the applicant reflecting the main point of her research, so 15 minutes. Questions to the applicant, strictly on her report, no more than 2 minutes for each speaker, and answers of the applicant. All members of the Dissertation Council speak in turn with their reviews, with their positions, questions, and suggestions to the dissertation applicant. No more than 10 minutes for each speaker. And a speech of the chairman with his answers of the applicant and remarks of members of the Dissertation Council. Open discussion. Speeches at request of those present at the defense procedure with a summary of their positions and specific questions and suggestions to the applicants strictly related to the topic of the study, no more than 5 minutes per person. At that, all the interested parties are kindly requested to register in the registration sheet and introduce themselves in full before speaking. That will be followed by the final answers of the applicant to the questions asked, no more than 5 minutes. A speech of the scientific advisor, no more than 3 minutes. A discussion before open voting to make a conclusion on awarding or not awarding the degree of St. Petersburg University to the applicant. For the time of this discussion, the broadcast shall be disabled. Open roll call voting, counting the votes, and the result will be recorded in the minutes of the meeting. Making a decision on awarding or not awarding the degree, final word of the applicant, no more than 2 minutes. Before I proceed with the procedure, let me remind you to switch off your mobile phones. Thank you for your understanding. I would also like to inform you that our meeting is being recorded and broadcast live on the website of St. Petersburg University, and the speeches are being simultaneously translated from Russian into English or from English into Russian as where appropriate. Let me proceed with the Chairman Summary Report. Our first item, Chairman Summary Report. thesis by Anastasiya, Pavlovna, Shirokolobova, specialty 010109. This optimization method for assessing demand for transfer between transport hub was accepted for protection for defense by the order of Academic Secretary of St. Petersburg University on the 11th of April 2019, order number 3599/1. The Dissertation Council was appointed by the Academic Secretary of St. Petersburg University on the same day, same order, and I have already introduced its composition to you, dear colleagues and guests. The applicant submitted the following documents to the Academic Secretary, which I have here. An application addressed to the Rector of St. Petersburg University, Professor Kropotchev, accept the thesis for consideration and defense, submitted on the 8th of April 2019, a review of academic advisor Zakharov Viktor Vasilyevich, Doctor of Physics and Mathematics, Professor, Head of the Department of Mathematical Modeling, and of Krylov, Doctor of Physical and Mathematics, a list of 18 publications which set out the main scientific results of the thesis, including 4 articles and peer-reviewed publications from the list approved by the Minister of Education and Science, and 4 articles in publication included in the international database and citation systems. A certificate of passing candidate examination dated 12th of July 2018, number 048252, issued by St. Petersburg State University, stating that Anastasiya Pavlovna Shirokolobova passed the examination in specialty 010109, discrete mathematics, mathematical cybernetics, history and history of science, good, English, excellent, discrete mathematics and mathematical cybernetics, excellent. A diploma, graduation from postgraduate course, mathematical cybernetics, thesis in Russian and English on paper on the rights of manuscript and in electronic form. The thesis is designed in accordance with the requirements of GOST R7.0, that printed on a multiplier device with indication of output data according to the GOST. It should be noted that all the documents listed above comply with item 12 of the section 3, presentation and defense of dissertations and procedure of awarding degrees in Petersburg University. Annex 1 to the order. Okay, let's proceed to the brief presentation of the applicant, no more than 15 minutes. Good afternoon. I would like to present the results of my research on optimization methods for estimating demand transfer between transport hub. My scientific supervisors were Professor Viktor Vasily Zakharov and Associate Professor Alexander Yuryevich Krylov. The purpose of my work was developing methodological tools and effective algorithms to assess and restore the values of demand transfer between transport hub. In order to achieve this, an analytical study of the tasks arising here to assess the demand for transfer according to an algorithm for solving the corresponding tasks, a two-level optimization were developed. The main results of the dissertation work submitted for defense are the following. Existence and in case of solution of problem inverse to the problem of equilibrium distribution transport flows have been obtained. In a number of cases for networks of non-crossing routes, it was possible to find an explicit type of display function. In general case, the mathematical two-level model estimation of demand from transfer on the given estimations of the network load has been constructed. The methodology and algorithm for estimating the demand for transfer between departure and other areas for large transport networks on the basis of two-level optimization models have been developed. Within the framework of this study, the transport network is modeled on the oriented graph G. W denotes a multitude of departure-arrival node pairs. Total transport demand for the movement between each pair is F large W. XE defines the arc flow. The cost of moving each individual vehicle along the arc is characterized by a continuous and strictly increasing flow function. When modeling the load of transport network arcs according to the given values, the behavioral principle is used, which is called the first principle of Wardrop, or competitive equilibrium. Between each pair, there's a lot of routes, RW, and flows on them, FRW, the total flow through which is the flow between the pair of regions. The Wadrow principle assumes that the flow is distributed in such a way that the time taken to move along all the routes is the same and less than the time the vehicle will take to deviate from this condition. This is reflected in this slide in Formula 1. The solution to the next optimization task satisfies condition 1, what Beckman first demonstrated back in 1956. Thus, the task of distribution of transport flows is to find the network loads on a known set of pairs of departure and arrival nodes and the values of demand for transfer between them. It's natural to consider the inverse problem, to search for sets of departure and arrival errors and to estimate the demand for movement between them by the unknown load on transport network arcs. Let us formulate such a task. For this purpose, we will introduce the following sets, F Gothic, of all possible corresponding matrices on the corresponding network, and X Gothic from F, all the possible distributions of flow satisfying all balance ratios for the corresponding correspondence matrix F. Let's introduce the Gothic Z from the set of all possible correspondence matrices into the set of flow distributions with the Gothic function. The task of finding the image of Z Gothic mapping will be called a direct generalized task of equilibrium distribution of flows in the transport network. The inverse generalized problem of the equilibrium distribution of flows in the transport network will be called the problem of finding a function Gothic mapping from the image of Gothic to the set of all distributions. For this Gothic mapping under fairly natural conditions, when the graph is strongly connected and the arc cost functions are continuous and positive, it's possible to prove seriality, which from a practical point of view means that there will be a solution to the problem of inverse equilibrium distribution of transport flows. That is, for any distribution of transport flows satisfied in the balance relations, there is at least one corresponding correspondence matrix. However, the injectivity and consequently the efficiency of this method is not guaranteed. Indeed, if we consider a network represented by four apexes and four oriented arcs with given identical delay functions depending on the flows on the corresponding arcs, then two different sets of correspondence will correspond to the same distribution of flows on the arcs of the network, as shown on this slide. At the same time, we managed to prove that if the double set is specified, is not known, the display is not biased, which, from a practical point, means the uniqueness of the solution to the problem of the inverse equilibrium distribution transport flows. That is, each distribution of transport flows in the network corresponds to a single correspondence matrix. Yet, in the general case, the efficiency cannot be guaranteed. Means a non-uniform corresponding matrix can correspond to each distribution of flows. The set of these possible corresponding matrices will be called the set of solutions of the problem inverse to the problem of the equilibrium distribution of flows. It's possible to establish the criterion of unambiguous determination whether a particular matrix is a solution to the problem inverse to the problem of equilibrium distribution given on the slide, where F is the transformed correspondence matrix to the correspondence vector. The delta is large, the matrix of connection between flows on arcs and flows on routes. Let's consider a network of non-crossing routes with one pair of departure-arrival points. Let's consider that a function of expenses on arcs has the following degree of appearance. Direct and inverse generalized problems of equilibrium distribution of transport flow for such a network in the introduced designations will be formulated as shown on this slide. In this case, it's possible to find an explicit type of G mapping function from X. In the case of a network of non-crossing routes with a linear arc cost function, the display function becomes even simpler. The results presented are published in the following peer-reviewed editions. Other parameters that characterize the transfer network load are travel time values. To describe this situation, a double task is used by virtue of the Lagrangian function to the task of equilibrium distribution transport flows. Thus, the task of searching for the equilibrium time of movement is to find out time spent on an unknown set of pairs of departure rather than the demand between them. It's natural to set the opposite task, to find many pairs of departure arrival areas in movement demand values by time consumption. Let's enter a set of T Gothic for all possible times of travel along the arcs and routes that meet many constraints. Let's see the Gothic grid display from a set of all possible correspondence matrices in the set of time costs with the Gothic Y function. The direct generalized task of searching for the equilibrium time movement given in the oriented graph will be understood as the task of finding the image of Gothic Y representation. By the opposite, we understand the problem of finding the Gothic function of a representation of K Gothic from the image of Y Gothic into the set of all possible correspondence matrices. Again, for this mapping of K under quite natural conditions, seriality is proved. From the practical point of view, it means that there is a solution to the problem of the inverse to the problem of searching for the equilibrium time of movement in the transport network. That is, for any admissible time costs, one can find at least one correspondence matrix. Again, in the case where many pairs of departure points are specified and not unknown, the Gothic K mapping is, which means from a practical point of view that there is only one solution to the problem of searching for the equilibrium time in the transport network, which means any admissible set of time costs corresponds to a single correspondence matrix. If we consider a network of non-crossing routes with the next degree of our cost function, the Gothic K display function can be explicitly written out. In the case of a line network, the display function is even simpler. If common arcs appear in the network of non-increasing routes, the travel time may increase. This paradox is known as the brass paradox. It's usually a formula for networks with characteristics presented on this slide. We have considered a more general case of the network from the point of view of the time expenditure function and obtained an estimate of the value and of free movement time along the common arc in which the brass paradox is manifested, where the following designations are used. The above results have been published in the following publications. It should be noted that transport engineers are now using the following two-tier optimization tasks in their work. This is the demand for transfer. The key feature of this is the use of so-called correspondence matrices. That is, the search for the demand for transfer is reduced to the specification of this a priori information. In our opinion, this assumption that there is a priori correspondence matrix is too strict. In this connection, the task of estimating the demand for transfer through the given values of network loads without using a priori correspondence matrices will be as follows. Note that based on the results already presented, the corresponding tasks of estimating the demand for transfer in the case of network of non-crossing routes with advanced time functions can be obtained in an explicit form, as shown in this slide. For a more general case of time expenditure functions, it has been proven that the solution to the problem of estimating the demand for movement and the network of non-intersecting routes can be found from the known load of any of the used arcs. The algorithm of solving such a task is presented in this paper. In general, the assessment of the demand for transfer requires a solution of requires solving the next two-level optimization task. The direction of the descent for the solution of such an optimization task cannot be set. We propose the heuristic algorithm to solve the two-level problem of estimating the demand for transfer according to data load in the output transport network. The application of the developed algorithm on the test networks has shown that the probability of finding the right correspondence matrix increases with increasing the number of iterations of a heuristic algorithm. On the real transport networks, the assessment of network loads can be made either directly with the help of car counters or indirectly with the help of information about the time of travel on the city's road networks obtained through online traffic monitoring services such as Yandex Maps. At the same time, the dependence between the traffic flow and the time of movement along the network is usually assessed by the following kinds of degree functions. However, as the numerical experiments have shown, depending on the initial data, one or another model should be used. Indeed, a sensitivity analysis of the problem of estimating the demand for movement between nodes of the network, depending on the type and time expenditure functions, was carried out on the example of a regular network. It was found that the network was simulated with a single degree of all delay. Then the travel demand models based on the information on the number of passing traffic should be applied. If the network was modeled more subtly, it was better to use models based on the actual travel time between nodes in the hubs in the network. On the basis of the data from Yandex Maps, an evolutionary algorithm has been launched to find a solution to the problem estimating the demand for travel on St. Petersburg network. It can be seen in the pictures below. It gave completely new values for approximately the same values of the target function. Thus, for such a network, it's better to use models based on information about the load of transport networks arcs, because the model is very sensitive to the time parameter. The results presented were published in the following works. Thus, the main results were published in 4 articles in the and 4 articles and publications indexed by Scopus. The results were also tested at various scientific conferences, Russian national and international conferences. In addition to that, our RFBR experts supported the project development methodological tools for assessment restoration the consequences of on large transport networks, in which I am the head. A part of the results of the work was used in the implementation of the project under the municipal contract. Thank you for your attention. Questions to the applicant, please. At least 2 minutes, not more than 2 minutes for each question. If we have no questions, let's proceed to the next point. Let's read out the reviews, including external reviews, if any. We have no external reviews, so let's read out reviews of the members of the Dissertation Council. Let's give the floor to Lyudmila Polakova. Thank you. Of late, many cities are close to exhausting the development capacity of their transport network. So the problem which Anastasiya addressed in her work is very relevant, especially for such big cities as our city. And with new instruments, new tools can be used to control the current transport flow, the dramatic development of computational instruments. It is now possible to coordinate traffic. Of course, a solution of such problems is impossible without mathematical modeling of transport networks. That is why it's very important to have efficient methods for this, and instruments can be used to assess demand for travel between transport hubs, to increase results of mathematical modeling of transport flow. It's necessary to develop new methods for solving this task. The thesis contains some important new results described in the sphere described. I have already described. The algorithm is based on the wardrobe principles. Anastasiya succeeded to resolve many tasks. She suggested new methods to obtain solutions, and one of the methods of this for solving this task was two-level optimization. The algorithm algorithms are not too many. Two-level optimization. She suggested a method which she successfully mastered, and moreover, she managed to study this task using database available data. She's made some test calculations where a transport network of St. Petersburg was used as an example. This is a remarkable fact because, in addition to developing theory, the applicant addressed a very relevant practical issue. Yet, I have some comments. My first comment is when proving the equilibrium distribution of non-crossing routes. It says that though the problem is of relevant optimization, there's only one solution to the problem. In my opinion, the problem in convex optimization. Sometimes such problems have more than one solution. In addition, there are the applicant mentions norm, but she doesn't explain which norm. And my third comment is more of a stylistic nature. In my opinion, when formulating theorems and consequences of the analytical type of mapping functions, it's better to use complex subordinate sentences with a conditional appendage. But this is more, so my comment it refers to the style. Yet this comments do not affect the overall positive impression of the thesis. And in addition, on the basis of this, I believe that the thesis on the order of optimization method to evaluate demands or travel between transport hubs meet the main requirements set forth by order for September 2016, number 6821/1. On the order of awarding academic degrees at St. Petersburg University. And the applicant, Shirokolobova Anastasiya Pavlovna, deserves to be awarded the degree of Candidate of Physics and Mathematics, specialty 010109, Discrete Mathematics and Mathematical Cybernetics. Clause 11 of the order has not been violated by the applicant. Thank you for your attention. Thank you. So maybe let's ask the applicant to answer the questions. Thank you for devoting your time. Speaking of your first comment, that there is more than one solution to the problem, I would like to note that the proof of uniqueness of the solution of the problem 222, 224, in case of strictly increasing time expenditure function, can be found, for example, in Leblon 1973 work. Of course, I would agree that this should have been clearly stated in the proof of theorem 219 by indicating the corresponding reference. Speaking of the second comment about the norm, during software implementation of the developed methods of estimating the demand for travel, I use the Euclidean norm. Of course, we should have specified this in the paper. And about the style, I'll accept this. Indeed, with this formulation of the theorem, concepts might have been even more accessible and easier to understand. Okay, let's hear the review by how long do I have? No more than 10 minutes. Review by Professor Yerzin. I was very successful to review the thesis by Krylatov. So this thesis is complements his work because he analyzed equilibrium flows. And here, on the basis of equilibrium flows, if we calculate demand, these tasks are closely related. Then you can feel there's a mechanism. Once you know the flows, once you watch, monitor the flows, you can the correspondence matrix, and you can apply Krylatov's method and find a new solution and look using these two approaches if the two processes will meet. So it's that will be interesting to know. In a nutshell, I think this is a good work, which is well written. And so that's I actually had a hard time to find any drawbacks and shortcomings, which is a good thing. On the other hand, I had to spend a lot of time to do this. I am looking at my review, and well, the theme is highly relevant. We all live in big cities. St. Petersburg is a big city. Novosibirsk is also a big city. Dr. Raha and Bangalore. This is also the traffic is very heavy, and of course it's necessary to deal with these challenges. The problem the applicant deals with have been simplified, of course. She looked at isolated districts. So the model has been simplified, but of course we have to start somewhere. So that is natural start. Well, of course, let me deviate from my review here. Maybe it makes sense to look at parallel routes or consecutive routes. Maybe it makes sense to look at consecutive parallel graphs and using dynamic programming, for example, to obtain some results. Use the same method, but for separate parts of subgraphs. But that's more of a wish for the future. The theoretical something to novelty. I'd like to say that assessing the travel demand has been described as demand for inverse. Has not been described earlier by any researcher, so which is a contribution of the applicant. Identified results for a single solution. I will not. It's obvious which task. She identifies some obvious tasks when you had linear function. Not only a linear function, a degree function. When linear function, with the linear function, the expression was simpler. Developed new model for demand optimization. Maybe here that means two-level programming. Speaking of the two-level programming task, well, the task was set in a specific way. There is a description and other possible descriptions. If look at the wardrobe principle, if we consider wardrobe principle, there are two levels. A first level is a second wardrobe principle. Is somebody has to control the flow of traffic, and the second level is that every driver wants to optimize his route. So what are the rules? What rules can be implemented at a higher level so that each driver could optimize his purpose function and maintain the equilibrium in the system instead of wasting time in traffic. What else? Speaking of comments, criticism, there are some misprints which maybe I should not mention. My main comment, I have already mentioned to Alexander Yurevich, the author only looks at growing functions, delay functions, and I understand that these are. It's easy to deal with those. Yeah. Yet in reality this is not the case. We know that if in the beginning we have a small flow, before the flow becomes big enough to change the speed of traffic, the time of travel will be the same. That will be a constant value that that doesn't depend on anything. That will not be a linear function. That will be a constant value. And then after a certain point, a linear fragment will start. And when traffic jams start, there'll be a dramatic change in time of travel. And obviously, modeling traffic jams is very difficult. And of course, it's easier to model increase in road capacity, the increase of road capacity. But I think that this strict growth is not necessarily the case, or maybe it's rarely the case, and maybe it makes sense to look at some interval functions where first the function is constant, linear, degree, and each function will correspond to a particular state of the a condition of the network. So, but this is more a wish for the future. The work has been enough publications. And in conclusion, I'd like to say, not to make the thesis of Anastasiya Shirokolobova, optimization methods for assessing demand transport network meets the key requirements set forth by the order already mentioned earlier, and the applicant deserves to be awarded the degree of physics and mathematics specialty 010109, discrete mathematics, mathematical cybernetics. Thank you. Thank you. So we have, seems like we might have a big discussion, but please remember that you have only 15 minutes to deal with all the questions. Dila Lyasevich, thank you very much for your time, for reading my thesis. Speaking of misprints, of course, I agree with your comment, and I should make the necessary corrections. Speaking of your first comment, will be interesting to use more complicated functions of delay. I agree, and there can be different models of distribution of traffic. For example, where load on other arcs is taken into account. In general, formalization of such models is done with variation expressions. In my work, I focused on the class of problems with strictly increasing additive functions of delays, because in this case the formalization of the equilibrium distribution transfer flows is possible in the form of task of conditional optimization, and the task of estimating the demand for travel in the form of a task of two-level optimization. But I totally agree that results should widen the results. Thank you very much.
Okay. And
Dr. Raha, can you read out your review? Dr. Raha, can you hear us? Time to read your review of the thesis, please. Dr. Raha, can you hear us? Hello? Dr. Raha, can you hear us? Hello?
Yeah. So I can hear you. Can you hear me?
Let's take a short break. Let's take a short technical break because we can hardly hear you, Dr. Raha.
Okay. So can you hear me now?
okay, now almost.
Okay. Dr. Raha, please read your review.
I can hear you clearly. Can you hear me now?
Yes.
Yes. Okay.
Yes, we can hear you.
Okay. So you can hear me, right? Can you confirm?
Yes, yes.
Oh, thank you. Okay, and then I can say some short things about this. So, so some of the strengths on the thesis I can elaborate, and so I like the approach to the equilibrium travel time and the Brace paradox. This especially like this small relationship theorem 1.18 that she has derived for the Brace paradox to be active in a network of 4 nodes. It's a nice calculation. And then there are other results also on the travel time and then like derivation of certain conditions in terms of the rank of the origin destination matrix. That is also a good result. And so overall, the thesis has a good contribution to inverse equilibrium traffic assignment problem, and this is so one thing, like probably it can be considered in the future, like whether like the assignment in the sense of like in the L0 norm, like can be considered in the future, like just so that is one consideration that can be looked into. And finally, look, apart from Brace paradox and equilibrium travel time thing, finally another good point is the sensitivity analysis is for the for estimation of the travel time problem and the traffic demand problem, and that is also a good result. And overall, I think it's a strong thesis, and it can go through for the award of the degree. Thank you.
Спасибо большое, доктор Раха. Анастасия Павловна.
Okay, thank you very much. Dr. Raha, can you please answer Dr. Raha's concert? Thank you for taking part in the Dissertation Council and for devoting your time to my thesis. Speaking of your comments, I would like to answer your first comment. You asked if it is possible to can you use for bigger networks. no zero demand for the travel. Once the space has been identified, it's necessary to launch a procedure to refine the actual demand values. On the test example, the method has shown its efficiency, and adult in our future research, we plan to expand the application of this approach to real transport networks. And speaking of your second comment, where you suggested visualization, in the last slide, you may see there are demands. And for this situation of paragraph 2.4, I identified several regions. And speaking of your third comment about misprints and spelling mistakes, well, unfortunately, I could not avoid them altogether when writing my thesis. I hope this did not interfere with you reading and understanding. Did you translate your thesis in English? Well, that's impressive. So you translated your thesis into English. Yes, as I mentioned in the beginning, the thesis was submitted in 2 languages, and well, both versions are available at the website. Dear colleagues and guests, let me. I will not read my entire review, and I will not compliment. I will only mention that strong point is high relevance and practical value of the work, and the big theoretical contribution, which should not be. I will not repeat. I will proceed to. Well, I have 10 comments. Not all of them are critical, but I will read all my comments. The author of the thesis points out on page 8 that one of the problems of modern modeling of the distribution transfer flows is insufficient level of formalism. Nevertheless, in the thesis itself, despite the excessive use of Gothic symbols, some important concepts had not been formalized. For example, the correspondence matrix, linear, nonlinear network, etc. The main results of chapter 1, with the exception of paragraph 1.6, have been obtained under the assumption of strong connection of column G. It should be explained how realistic this assumption is in practical terms. Third, the results of theorem 1.5, the results of the Kronecker-Capelli theorem. The use of the form 1.2, page 17, 2. Page 40 requires clarification. Page 31, above the formula 120, there's a misprint. Lagrange multipliers are marked as X or Y, which is not the case. 6. The results of point 1.6 do not correspond to the general logic and structure of the thesis. When studying the Bryce paradox, the strong connectivity of the graph is not used. 7. Algorithm point 2 is a heuristic. To find departure rival pairs, the construction of a linear trend is doubtful. Most likely, this approach selects the first average values with the lowest values of the target function. In general, the lack of formalism and the descriptive nature of the problem should be noted in Chapter 2. Number 9, determined imperant model of Chapter 3, page 78, is basically contains a probabilistic approach, so the name is unsuccessful. And finally, Chapter 3 contains a large amount of abstract information that is not sufficiently differentiated from the author's results. Yet, in general, well, these comments do not affect the overall high good impression of the thesis. The thesis is a valuable piece of scientific research, and validity of the results is obvious and well demonstrated by publications in peer-reviewed magazines. And that is why I believe that the thesis of Anastasiya and Shirokolobova, optimization methods for demand evaluation for travel between transport hubs, meets the key requirements set forth by the order number 0109/2016 on the order awarding academic degrees to Petersburg University, and the applicant Shirokolobova Anastasiya deserves to be awarded academic degree of Candidate of Physics and Mathematics, specialty 010109, discrete mathematics, cybernetics. Clause 11 of the above-mentioned order has not been violated. Thank you, Dr. Gromova. Thank you, Dr. Gromova. Thank you for your time and for your valuable remarks. Let me answer your remarks. First, about insufficient level of formalism. Thank you for this comment. In scientific literature, the corresponding message is well established, and the concepts of linear and nonlinear networks are also well established in the field of equilibrium distribution of traffic flows. The linear network is often understood as a network with linear functions of time expenditure and the nonlinear functions of time expenditure. Indeed, in the thesis it was necessary to define these concepts explicitly. The connection of graphs, strong cohesion of oriented graph implies a path from each vertex to each vertex. In a real network, you can always go from point A to point B and back along some route. Thus, the assumption, in my opinion, is quite realistic. The results of theorem 1.5, the result of Kronecker-Capella theorem. Thank you for of course, from an algebraic point of view, the results of theorem 1.5 are based on Kronecker-Capella theorem, but at the same time, these results have no practical meaning without taking into account the properties of equilibrium distribution of traffic flows. Functionality of the form 1.2 and 2.4 is the functionality of the form 1.2 and 2.4 is the target function of the equilibrium distribution of transport flows. Such formalization was first proposed by Beckmann back in 1956, and at the same time in his work he clearly stated that this functionality has no physical or economic sense, but stems from mathematical calculations. I would like to note that the recent work of Professor Molozomov shows that that the type of this target functionality directly follows from the generalized Gibbs lemma. However, again, the researchers do not comment on its meaning. Comment number 5, Lagrange multipliers. On page 31, they investigate the dual problem for the equilibrium distribution of transport flows, and thus the variables of the straight problem xi acquire the meaning of the Lagrange multipliers for the time variables of travel along the arc xi. That's why I use these symbols. About the Brass paradox, common arcs appear in the network of non-crossing routes. Can increase time travel, so which is called the Brass paradox. In this paper, we consider the more general case of time expenditure than in the classical formulation, obtain an estimate of the value of free travel time on the common arc in which the Brass paradox is manifested. Can be manifested. This point follows just after the study of time cost estimates in the networks of non-crossing routes in the case of equilibrium distribution of flows. And of course, we should have written down this meaningful connection of point 1.6 with the previous 2 points. Speaking of linear trend and your approach that you suggested, thank you for your comment. If we consider the test network presented in Figure 6 in the thesis and compare the results of the application of the heuristic algorithm and the method based on the search for the first average values with the that you suggested, Indeed, it turns out that both approaches lead to close suboptimal solutions. However, the method of averaging the first values is limited only to finding some suboptimal solutions and does not indicate in any way in which direction it can be improved. At the same time, the trends identified as a result of implementation of the heuristic algorithm, the rich pair of nodes, show the most probable directions of change in demand values towards improvement of the obtained suboptimal solution. But that is. Chapter 5 and lack of formalism. Chapter 2 was dedicated to computational methods, estimating the demand of travel between hubs, and was based on formalism introduced in Chapter 1. From one of the objectives was to give substance to the formalism in order to demonstrate its practical usefulness. I agree with the word that the word determined model was badly used. There was secondary importance in this study. And finally, chapter 3 contains a large amount of abstract information, reference nature. Indeed, chapter 3 demonstrates the connection between the existing methods of information collection and the models that have developed to estimate the demand for travel. And I agree that we should have more clearly identified our own results. And thank you again for your valuable comments. Dr. Gromova. Let me use my privilege as a chairman, and in that sense, maybe I don't have to read all the details, yet it seems that a wide discussion of new tasks. So I'll try to stick to the formal structure of my review. Of course, the task of optimizing traffic flow is very relevant, not only in big cities, but now we're talking about 5G communication networks, where the routers. Many companies have visited us, so this is a very relevant task. And it's very interesting to see that traditional approach, the mathematical approach. Since we are mathematicians, let's find a problem that will address travel time from point A to point B. But on the other hand, as practical researchers, we know that this is very unstable. With even a slight data in input data, the result will be very different. You can choose a short route to go home from your summer house, and then there is an accident, and the travel time will be much longer. And at the same time, it's very. This was a very good time to deal with other tasks. Such as equilibrium distribution. I think this is very important and very relevant and interesting because these tasks, through the point of view of equilibrium distribution, have very robust and very can sustain such changes. On the other hand, they enable us to find more effective solutions, find better mechanisms. We want to find a good solution, local algorithm, which look at the differences and can produce a balanced solution for global. Thus, we get a good solution to a global task. On the first level, we need a centralized decision. Second, as was mentioned already at this today, in case we describe functionality in a particular way, it's possible to address a problem, to solve a problem in the optimal way. Good strong point of the thesis. The thesis is well structured. And I agree with some comments made by my colleagues earlier about the style, but generally I think this is a very well written piece of research. Speaking of chapters, chapter 1 deals with flow distribution. Chapter 3 describes existing approaches. Chapter 3 describes practical applications of suggested models and how different methods of collecting information on the traffic network, novelty and practical value. or obvious because the author creates a two-level model and to evaluate demand, which provides new opportunities for analysis and managing transport flows in heavy load networks. In addition, the author studies conditions of existing revert problems to equilibrium distribution of transport flows, and for non-linear functions she suggests algorithm of solving the task. Practical value of the work depends on its orientation on efficient use of models and methods for assessing demand for travel between transport hubs, which was presented at several international conferences. Speaking of comments, I have already mentioned some of my comments. Well, maybe second wardrobe principle can be used. My other comments are quite formal and already been mentioned by my colleagues. Maybe one comment I would like to say again. As we had editors earlier who so when you write about information, so data, that's experimental data or arrival data, but this is not data of the project. In English you have data, and so you have many English articles, and so maybe in legal or medical, it's better to use the different words, different terms here. Yet these comments do not affect the overall high impression. Well, the main results have been published in national, international magazines and peer-reviewed journal from the list presented at international conferences. And the thesis of Anastasiya, Pavlovna, Shirokolobova, optimization methods for demand evaluation for travel between transport hubs, meets the main requirements of the order of 6821/1 on the order of awarding academic degrees at Petersburg University. And the applicant, Anastasiya Pavlovna Shirokolobova, deserves to be awarded academic degree of Candidate of Physics and Mathematics, specialty 010109, discrete mathematics and mathematical cybernetics. Clause 11 of the above-mentioned order has not been violated. Thank you, Dr. Granichin. Thank you for your time, and thank you for being the chairman of this council, and thank you for your comments. Let me take the two comments that you just made. Using the word data, I agree. The word data should be used with more care. There is research where it is understood as informational data. And speaking of your first comment about the main approaches, thank you for this comment. Automated system of distribution of traffic flows in the city, working on the basis of multi-agent algorithms, can be a more effective means of traffic management than a centralized navigation system. And in this sense, the qualitative description of the second principle of wardrobe in my work really should be specified. And nevertheless, I would like to say, and in my study, I had to rely primarily on the first behavioral principle of wardrobe, which allows you to model the competitive distribution of users on the transport network, which was an important semantic basis for the models I developed. Thank you for this comment. Thank you very much. Okay, let us proceed to the next item on our agenda. Well, anyone present may speak now who's not a member of the Dissertation Council, no more than 5 minutes. If no one wants general comments of the applicant, I think I have answered each reviewer individually. Thank you very much for your comments, and I will certainly take your comments into account in my future work. Now let's give the floor to the academic supervisor of the applicant. We have not more than 5 minutes each. It happens so that we have 2 academic advisors. I started this, and then 5 years ago I finding the correspondence matrices on network load is very relevant, very important. And then I formulated this task to Anastasiya. She was still a master's degree student, or maybe so this was a very challenging task for a student, but its relevance is obvious because at the last event, the economic forum, participants discussed reconstruction of the road network in St. Petersburg and with the semicircles, with help of semicircles. And when I spoke to one of the experts involved in this, the correspondence matrix will be useful, and he said yes, that's exactly true, but how these correspondence matrices are being calculated is not clear, because we can all see that we can all see how many traffic jams where they don't have exits. And we all see really bad traffic jams, which means the correspondence between the points, between the hubs. And Anastasiya was very well organized, very well motivated, and the fact that during these 4 years she managed to publish 18 articles. Complete and at least 8 are substantial articles. I think this is really cool, and this does not happen often. So let me congratulate Anastasiya on her hard work, and I think we should support her. And I'm asking you to award the degree to Anastasiya. Thank you. On my behalf, I would like to mention to describe Anastasiya as a very hard-working person, not only a researcher, which you could already see during her presentation, so dear members of the council, but also in implementation of some real-life projects, as she mentioned. Under my guidance, we completed the project on optimization of transport network of the city of Omsk, where the primary task was to determine the correspondence matrices. And of course, in that project, we used existing and very simple and primitive instruments. But if we have not started our work earlier, we would not be familiar with these instruments, and without the involvement of Anastasiya Shirokolobova, we won't be able to be so successful. We won't be so successful. And they sent us a very positive review. The mayor of Omsk awarded us a prize from the transport department of the city. So I hope this fact will not pass unnoticed. That is why let me wish lots of success to Anastasiya. Thank you for being so focused and hardworking, and I hope that she will continue her work in the future, and in the framework of the science project, where some money is being allocated towards development of some young scientists, and her qualifications will allow Anastasiya to win grants in the future and to make good money as a scientist. Thank you. I wish you lots of success. Thank you very much. The next point on our agenda is a discussion, a 5-minute discussion of the council members. Let's discuss on awarding or not awarding the degree to the applicant. For this period of time, please stop broadcasting, and I'm also requesting everyone present who are not members of the council to leave the room for 5 minutes. So please don't go away, don't go too far. And I will invite you to come back after the discussion is over.
think
let us resume the session of our Dissertation Council. Please start broadcasting. The most important moment of our session has come. I now put the issue of awarding or non-awarding the degree, awarding the degree. The decision shall be positive if at least 2/3, but not at least 3 board members vote for the decision according to Article 23 on the order of awarding academic degrees. It's in Pittsburgh University. Member Dr. Gromova, I support awarding the degree. Dr. Polikova, I am for awarding the degree. Dr. Yerzin, I'm for awarding the degree of Candidate of Physics and Mathematics. Thank you. Dr. Raha, what is Dr. Raha, are you for awarding? Or, do you think Anastasia should be awarded the degree? Does Anastasia deserve the degree?
Yeah.
Please say
is
yes.
Fine. Yeah.
Please.
So I go with the council. It is okay.
And
Председатель Совета Граничный Олег Николаевич, я тоже поддерживаю.
And chairman of the board, Oleg Granichin, I vote for. Okay, let's count the votes. Dear colleagues, dear guests, let me announce that out of 5 members of the Dissertation Council, 5 voted for awarding the degree, no one voted against, and no one abstained from voting. Well, the decision on awarding the degree of Candidate of Physics and Mathematics, specialty 010109, discrete mathematical has been passed. Anastasiya, Dr. So finally, let me say thank you to the members of the Dissertation Council for their time they dedicated to my work. This is very valuable. Thank you very much for your time. I would like to thank my academic advisors for their support, for their time, and for their efforts. Thank you very much. The meeting is now closed. Thank you, everybody, and please stop broadcasting. Thank you, everybody.